So I'm adding coverage to the Flying Burma project. This is actually something that I should have done before, but I didn't. And coverage is a great tool to kind of weed out the last little issues with the code. And it's very easy to miss things, like, because if you don't do coverage, you never know if your tests are actually testing everything. And if you don't do the tests, then you never know if your code actually works. So things like, for example, like little trivial bugs are easily discoverable using tests. For example, if I have if I would have missed this equal sign there, this would show up on the coverage data, because if I would test if the motion was completed and supply the time that is exactly the last timestamp of the move, then I would see a red line here if it wasn't covered. So I would see that this is actually this comparison is actually wrong. This is what I'm going to be doing right now. I'm going to be going over the code and kind of writing the tests and fixing any little issues that I find, so that we can do the final testing on Monday. Okay, let's see here. So I'm just going to format this. Let's see, format, so that we get nice looking formatting on the code. I'm going to rerun make check and make coverage. Let's see. Right. I may need to delete because I moved some files and there's some GCDA files that are still left in the tree. Let's see if they have been removed here. Yeah, this is what you get from gcov when it finds some GCDA or GCNO files which haven't been deleted, and because clean cleans out the files that belong to the stuff that already exists in the tree. I should actually delete all of the files, all of the GCNO files when I do the clean. Let's see here. We can possibly add clean coverage here. Let's see. Right. So this script doesn't actually clean out the coverage data. Let's see what we actually need to clean. GCNO and GCDA. So this seems to be returning only the files that I need to delete. How do we actually do this? How do we actually search for multiple patterns? Find multiple patterns. Right. more name GCNO. Oh, yeah, of course. There we go. Why is Emacs not indenting this properly? This is weird. Like, why does it think that it needs to indent it like that? Sometimes Emacs just doesn't do what it's supposed to. Okay. Let's see. What is going on? Come on, this is ridiculous. This is absolutely ridiculous. Like, why is it not even inserting a tab? Shit. My configuration, there's something is totally screwed up about my configuration. Because I've been sort of redoing the tabs configuration in different modes, and I must have screwed something up with my tabs configuration. So I get this. It's obviously it's trying to align this, but this is not correct for the make file. Oh, I see. I know what the problem is. So because I named this make file AM coverage, it's not actually treating it as a make file. So it's treating it as text, and in that case, it's actually correct. So let's fix this. Let's rename this to make file coverage AM. And then we can do like this. Yeah. Okay. Now it's working better. Recompile and let's see. Yeah, and then build there. Should be able to clean this out now. Let's see, why is this missing? need to clean out everything, and I need to rebuild it to generate the files again. And now I should get the coverage information, because since I didn't rebuild all of the source files, I didn't get the gcop files generated for all of the source files. So now it worked. Okay, now we can go back to the coverage here and reload this, and we get the yeah, that's good. I wonder if this got somehow optimized away or something, because I'm pretty sure it actually returns true there. So these lines are cold, but they're not. They don't actually show up in the coverage. Let's see. Maybe I can do like this. Let's make it optimization 0 by default. And then we need to also make sure that we don't use optimization 0 in the embedded build. I would actually need to add a conditional for the optimization flags, because optimization flags are set on the top level here. So when I call the main build script, it sets the C flags for the whole build, for anything that goes into the build. So I get the optimization for size, but when it comes to coverage, we need to actually disable the optimization completely to get proper results here. Although it doesn't really matter for the percentage that you get in the coverage here, because the lines that have been optimized out, they're not showing 0. So they have just been optimized out. So this is kind of like, I think this is probably okay, because it's the purpose of the coverage is just to see what has not been executed. It can be a little bit harder to read to get the right values when you're debugging, when you have optimizations enabled. But from the perspective of like, you're not going to miss anything if you have them enabled. It's just going to be a little bit less information in the output reports. So I'm gonna just remove this O0 there in the coverage make file. For now, we'll just go like that. Okay, I need to clean up a little bit more here. I want to move out the code that outputs the values to the motors, because I have 2 different functions right now, and they basically duplicate a lot of information, and I have to move them out from the main file, make sure that they are in a separate file so that I can unit test them. So I need to go to the motor output. So I have 2 different functions here, and one of them constrains the output. Also stuff like this I have to move to the config file. So we have the max pitch. This is going to be max pitch and min pitch. Those are the limits for the crane, which determine how what is the lowest position and the highest position of the crane. So if you haven't seen the video yet, I have a video on my YouTube channel where we do some initial testing, and you can move the crane up and down, and these values determine how far down or how far up the crane is allowed to move. So they should be configurable, obviously. But I've added this during our testing. So I'll move this out to the config. Let's see, I'll go to the config here. Actually, I'm going to show you the video. Let's see. So this is what it looks like, and it can go up all the way or down all the way, but it shouldn't go below the position which sort of where it hits the ground. It should never hit the ground with the tip of the crane, and it should never hit the ground with the back either. So those are the limits. So you can never actually go all the way with a linear actuator. You have to limit the values. So let's go here.
During an OSINT investigation, a subject's phone number.
Fuck off. Let's actually put this in the control, because this does actually belong to the control. And then we'll just do like this. So instead of going like this, we will actually just copy the values of the controller to the output variables. So then we can put the configuration values in the fbconfig control. Let's see. Yeah, so this will be the positional limit, and we can then also go to the control, to the config actually, the defaults. Let's see. So for the let's add for the pitch, we'll add these values. Yeah, so we need to have the minimum and the maximum as well. And for the yaw, we're not going to have any limits. I also have a few other settings here that I need to set. So where do I plan that? Let's see. So I need to copy the values from here. I have the values somewhere here, I think. Oh, yeah, actually, these are going to be copied from the limits which are set here. So this is my old way of setting the limits, but we have to copy them. So the pitch acceleration, let's see. This was not actually what I was thinking about. There should be another value somewhere which limits the acceleration. Let's see. Which I need to move out. Let's check the Git, actually. Also, these ones need to be added as the deadband for the joysticks. But there is one specific value that I want to change, that I want to move to the config, which is the maximum, for the automatic move, we need to configure the maximum acceleration and the maximum speed, which I have moved the code, but I haven't moved the actual configuration values. So I have to find where the configuration values were before I move the code. Could it be in the latest? There. It's related to this code, but there was let's see. There were a few lines also where I initialized this. Which I'm trying to find. Right, okay. So these values are actually the value. This was the correct value, but there is a little bit more to this because we need to move the code that calculates that value from the potentiometers. Let's see here. Or maybe we could just supply the values directly to the control class, because I've moved out all of the control from the main file now to a separate file. And I need to move the relevant parts of the code that are still in the main file. I have to move them to the FB control file. So let's see. We have the limit and because this is not a static value. This is a dynamic value which we configure using the potentiometers. So we need to supply the updated value to the to this function which is in the FB control, which initializes the profile here. But it's possible that we should actually take this limits value from the measurements instead of taking it from the config, because the config in this case is it can be read-only if this is a static config, and we shouldn't be changing values in the config if they're dynamic values. Let's see what the best way to do this is. So in the measurements, we would calculate this pitch and yaw. And all of the accelerations here and the speeds. So what we probably want to do here is we want the controller to use this value, but only when only at the start of the move. The values for the acceleration and deceleration, they shouldn't be changed during a move. So this has to be supplied to this to the control block, but it's going to be initialized only when the move is started, and not while it's moving. And should I also move the manual control to the same control block, or should I keep that control block only concerned with the automatic control? Right. So this stuff shouldn't be in the control block, because this is the value of the control mode. It determines where the position is taken from. So if you have a local control, it means that you are controlling with the same board. You're controlling the motors with the same board where you read the inputs. If you have a remote control mode, then the inputs are sent, or then all the processing is done on the input control board, and then the motor values are sent over the CAN bus. So this doesn't really belong to the control. So we can leave it out of the control. We can leave it out of the file FB control C. But we still need to probably move this function to that file and test it as part of the axis control strategy. So let's see. the whole idea with having the FB output constrained and FB output constrained fastest is basically that when we are running in manual mode, we want to control the speed of the acceleration and deceleration, as well as the speed. And when we are running in automatic mode, we don't want that those constraints to be applied to the output in the same way. But I think we could probably combine both of these functions. I just have to think what the implications of that would be, because I don't want to break anything while I do those changes. I just want to clean things up a little bit and make sure that everything is tested, so that I can be absolutely 100% sure that everything's going to be working correctly. So I need to think what the implications would be of changing this. I'll change this comment as well. This is a mode for manually setting the values without having any, without reading them from the inputs. So there is different ways of getting the inputs. We can send the inputs over the console using console command, or we can automatically read the inputs from the analog inputs on the board, or we can get the inputs from over the CAN bus. So let's see. I think we could probably simplify this by simply breaking out this part, the part where we calculate the pitch, the actual pitch demand for next time step, because when we're running in manual mode, we do it by simply integrating the pitch value and just increasing it at every time step. Whereas when we're running in automatic mode, then we get this value generated by the automatic controller. But it's still a good idea to limit it, but we just shouldn't be limiting it according to the values of the potentiometers, because that setting has already been applied in the automatic controller. Because we are sending the maximum acceleration and maximum speed into the motion profile when we do a planned move, then this obviously shouldn't be applied to the output values when they have passed through the automatic controller. But when we run in manual mode, then we need to calculate the demand manually, and then we have to use the pitch acceleration and the yaw acceleration, which is measured from the potentiometers. If we just take this out, let's see. So we have the demand is set. So the way this code has evolved is that I had the manual mode in the beginning, and then I've added the other modes. So that's why it's such a mess right now when it comes to how it actually calculates the values for the outputs. So I should probably move the other code here, because I think it's only used here. And instead of sending in the measured pitch and yaw, we will actually be sending in, let's see, we should probably also send in the acceleration as a value, because then we just have the same code here. I'm going to move this value of 4 here into the config as well. Okay, we can start by just doing like this. And then we can remove the other function. So this will then then the second step would be to refactor this function. And the fastest would just be using values of 1. And this is another fix that I did during the testing because the speed was halved. So this is a fix that needs to be implemented properly. For now, I'll just move this code here, and we can update this to self config. Suppose that would be, yeah, we can place it in axis. So pitch is up down, and this would be max pitch. That's correct. This was wrong. So like that. So now we could use this value. Emacs can diff to selected blocks. There's probably a way to do this. And this is something we want to do at all times. So this is not just something for the manual or for the automatic control. It's something that's supposed to be done at all times. So we can remove this one. I think they're pretty much the same. I think everything else is identical. And then we also remove this one. So now this code will be over here. And it's set. But the problem here is that okay, right now it's not a problem because right now we're just looking at the pitch. But if I later move this into the control block, then I have to make sure that we check for the limit value and not apply it for the yaw, because the yaw is going to be spinning around, and it's actually multiple revolutions per single revolution of the actual arm, because the motor makes many more revolutions, and then it's all passing through the gears and to the arm. And we don't want to do this limit on the circular rotation, because circular rotation is handled a bit differently. So if you can see in the controller here, I have two different code paths for the normal positioning control and then the circular one. Because if something is moving in a circle, we have to normalize the error. So we calculate the difference between the angles, and then we have to normalize that so that we always are around 0 and not so we don't get the wrong value when the angle actually wraps around when the thing rotates. So special consideration needs to be taken for the rotational motion. But for now, I think this should work. Of course, I'm going to make sure that it works by unit testing it, but I have to make sure that I don't miss something when I do changes like this. And before I unit test them, I have to make sure that I don't forget some little detail that actually should be there in order for this thing to function properly, because it's much more time-consuming later to try to find a bug that when you just move some code and then you miss something, and that results in a bug that is much more time-consuming to fix than to just think through it right now and make sure that nothing is forgotten, and then to properly unit test it to make sure that it's 100% perfect. So I'm going to try to recompile this. See if there is anything that has wrong names or something. We can close this one. And we have limits. Let's see. where am I using that value? Oh, right. Yeah. So this can use the same value for both min and max, because it's going to be either a positive or negative value, but it's essentially the same. So this is actually going to be let's call this integral max, not to confuse it with current. This value should be set to 1. For the defaults. Oh, yeah, of course. Let's see. Yeah, this was correct already. And then this one is going to be limits. So far so good. I have a single test that succeeds. I'm gonna add more tests. I'm using gtest for the testing. Let's move this to give this a proper name. Motion profile. Oh wait, I think it's actually, could it be that this creates an issue? So we'll add a new test here, FB control, sources. This will include source FB control, and it's going to include FB control. Let's see what else we need as well. Tests will have FB control. Oh, yeah. Always have to remember this. I need to add this line continuation. Okay. was a flag that was left from the first build I did with tests for this test suite. So we have a few functions that are missing. We're going to mock them for the test. Motion profile. So we're just going to be testing that the controller sends the correct values to motion profile, and the filter we could actually include into the compilation, because that's irrelevant for this. And let's delete that. Just reuse the standard set of methods here. We instantiate two objects, one for the controller and one for the configuration, and then we'll have test here that will modify the configuration and run the controller and make sure that the results are correct. So we have test fixture controller test. What could be of interest here? Control. Let's see. Make this 3, and then the input will be. So I'll also need to write a little simulation for the motion, just very simple, just to make sure that the controller is working, and then we'll feed the input position to the controller from this simple simulation, and then we'll take the output and use that as an acceleration, or in this case it's going to be the velocity value because we are controlling the voltage. If we were controlling the current, then it would be the acceleration value. We're going to set target to 3, and in the motion profile we can see that if we set could use a similar profile to this. And we're going to expect the output to be 0 and also to remain at 0. Let's clock this for 100 milliseconds. And we set the target, and then we have this move is going to take 5 seconds. And we can just have a little simulation here, sim pause and sim val, and they're going to be set to 0. And we can actually use the KFF value for the, let's see here. So this would be simval divided by we can set the KFF to 1 in this case. expect plot equals 0 after clock that is probably not going to be 0 because of the integral action. But the aim here is to run the controller until the move is done, and to make sure that the final position is at the correct position, and to make sure that the controller output is 0 after a certain period of time, which would be the period of time here would be the maximum settlement time, however many milliseconds that's going to be. But I think I need to run this just to see what results I get at this point. And we'll also include the config into the compilation here. When it comes to unit tests, I usually just include the files that are required, because I want to override methods of other files. And actually, the separation into different files is largely determined by, of course, relevant things should be in the same file, but also sometimes I split files just to make sure that I can include some part of the code into the unit tests, and maybe some other part is only included into the final build. So I only include the stuff that I need. And I'm actually liking the automake system more and more. I switched completely to automake for all of my projects now. So I use automake for everything. I feel that automake is much more powerful than CMake. It's been around for much longer, and it's much more suitable for seamless compilation when you have a lot of different files, and you can just specify the flags for everything, and everything just works. So yeah, automake is very nice, and especially the fact that I don't need to learn a completely new API for configuring the builds. I can use shell scripts, and I can use shell commands. I can use make syntax to define the builds, and at the same time kind of get all of this cross compilation logic built into the build system. So I feel that automake is really good. I'm going to be using automake more. So let's see, default, init default. Control, let's see, control is here. Init default. Right, of course. Let's make this a config, and right, so why not just do like this? So let's go back to using the config control and just do like this. Which is a good refactoring for the config. So config control is gonna go here. And this is basically gonna make all of this simpler as well. The config control. You can use like do while zero just to separate contexts. I could also use the just a curly bracket like that, but I find it easier to read if I separate context using do while zero. And then all of this stuff is gonna go in here. This is left, right, and let's see. There's a few differences, however. No, this is stupid. This is totally stupid. This is very, very stupid. We should actually have different settings here. Let's see, control init default pitch. No, this is getting too much. This is just getting too big. Too long name. Let's see. Let's just do like this in the test. So I take back that. That was not a good idea. I'll just init the config like that. And in the control, we could initialize the config like this. It looks like the stream is not being sent correctly because I'm getting a lot of errors. So it's possible that I'll have to stop the stream. Okay, it seems to be back up. So, let's actually just use a copied default config, because we don't really want to include the default values that are defined in the application, because those values can change, and that would break the test in a way that is not really doesn't really make sense. So it's better to just include this as a default here in the setup method. So we can do like this and do conf equals set this to 1 and initialize to conf, and can set that to 1 just to make sure that we expect 1 there. C++ is always going to complain about such initialization, so I have to do the initialization like this. Oh, yeah, of course. Right, good, that compiles. Let's format this buffer. We have formatted the buffer. And next step is to add the profile. And we're going to be adding this as extern C, because I'm testing C code with C++ here. And if I have functions that are being called by the C code, I have to always place them under extern C in the C++ file. Otherwise, they're not going to be found during linking stage. And we need these methods, so basically motion profile API. Let's copy them over and define them for the test. So these are going to be the mockup methods. They're just going to make sure that we can intercept the information. Let's see here. Do I actually need to mock them? Or can I just take all of the relevant information out of the motion profile trajectory object? I probably can. But maybe I need to, let's see here. Do I need to interfere? So the question, like, the question you should be asking when you do the mockups is, do I need to interfere with the process of with the data flow whenever those methods are being called by the C file that's being tested? So we can open a C file here and see if there's anything that's interesting to intercept or override. So it's kind of like the behavioral override that I'm interested in. Do I need to override the behavior of motion profile in any way? Which could actually be interesting, because if we're testing the control, maybe we want to make sure that the motion profile actually just outputs a value that that we just set from the C++ test code. And that can actually allow much more easier testing. So I'm gonna override this. So init doesn't need to do anything. Plan move. So we'll have just some variables here. And this will allow us to do much more interesting testing of the controller. Profile completed is also going to be a static bool. Plan completed, and we can have a motion profile state set to plan. So it's going to be plan state. Good. And this will copy the plan. Let's see. God damn it. Plan from pause. Current pause. Plan to pause. Is this will just return, so set point is going to be plan out pause and vel sp vel, and act sp is going to be plan out acceleration. Cool. Completed is just going to return the completed. So notice that we don't really care about some of the parameters to these functions, because we're going to be explicitly setting the values that are going to be returned by these functions to the controller. So now we can do a little bit more interesting testing. So test controller, let's see, this will be we're going to try to start a plan. So to start a plan for the automatic control, the previous plan has to be completed. But I'm going to split this into two different tests. So I'm going to have one that is going to test just to start a plan, and another test is going to test to starting a plan when another plan is in progress. So when we start a plan, we want to have, we want to make sure that the values that are being sent to the motion profile are the correct values. So we're going to do fb control set target. Actually, this is going to be the plan target position. It's going to have to be 0, and then when we clock the controller once, we're going to expect this to be 3. And if we start a plan here, so I'm going to just, I don't need to test that twice, so I'm going to remove that. Set target, set, let's see, actually I'm going to use the clock method here. So clock 1, and clock, well, let's clock this for 20 milliseconds. And let's see, the state of the plan always has to be, let's see, it has to be not completed here, so plan completed equals false, and plan state equals, actually I'm going to remove that state method. I feel that it's a little bit, either the state method or the completed method, because we should only actually just check the state. Let's see. I don't want to do any completion on that error. Thank you. Okay. Let's see what the controller is actually testing here. It's using the motion profile is so these two methods are actually going to return different things. So this needs to be refactored because there's one that's going to return completed if the state has actually been set to completed here, which it actually should be set to. So actually this test is redundant. Which means we should do like this instead. and the move can be completed, but let's see. I mean, it will only go to completed if it's actually been planned. So, can there be any case where it's going to be completed but not planned? No. So, profile completed should just check the state for completed. I wonder if my previous test for the motion profile is actually going to succeed when I made this change. That's interesting to know. And then motion profile plan state can be set to 0, which I think is the state that is, let's see, motion profile. Right, so this is not correct. This needs to be 0. So we don't want it to be completed by default, actually, because completed means that it has been run. So completed means that there has been a planning stage, an execution stage, and a completion stage. So I'll add just uninitialized as a default state. Let's make sure that it's actually initialized to uninitialized. Yeah, it's going to be set to 0. Cool. So state is 0, and this can actually be set here. And we should be resetting all of the values here to known values. By the way, this one is not needed. Okay. And then when the planning is done, so when we have the plan move, we could actually also set the plan state here to we have a plan. Let's just reset the plan. Or we'll actually let the tests determine what to do with the state. And here I'll be clocking this one clock at a time because So obviously this is not going to be correct now. When this move is executed, it's not going to be the move that I originally expected here. Let's see, now that's going to be plan target pause would be 3 and target val would be 0. Let's make sure that target pause is 0 there, just to make sure that, because we're let's see. Actually, this is supposed to be 0 there, but we also need to test this when we do the let's see, when we do the start here. Target pause and target val is 0 there. So this will test if the planning was successful, and this will test if the actually we can set the val. So we could set the plan target val to 1 and then make sure that it's 0 there. Let's make this 2 and 3 and make sure that it's 2 and 3 there. So if we just test it otherwise, with 0 there and 0, 0 there, then we are not sure if it's actually been preserved. We don't need to test that, we just need to make sure that it's preserved at values that we've set here. So, and not been reset. Yeah, 3 is fine there, but we can make it 4 just to make sure that it's easier to read here. So this value is supposed to end up in the position when the plan is planned correctly. And then the plan. So if it's planned during a move, then it's going to be the values are going to be updated once the previous move has completed. So we can actually test here as well that is actually happening by setting the plan completed or plan state to motion profile completed, and clocking this one more time, and then making sure that the position has been updated to 4. And I think that my logic is there's probably an error in this logic somewhere in the controller here, because we're using else if. So if I use else if, it means that if it's completed, if it's moving and completed, it's going to be reset here, but it's not actually going to be planning the next move in the same clock cycle. So we can do it like this. So if self moving equals false, if not moving and a new start is requested, then we replan and we start again. So this can actually, yeah, we can do like this. Start next move in the same clock cycle. I use clock cycles because it's a loop iteration, but I use clock cycles because I find that it's much easier to think about these discrete processes as being clocked. It's kind of like a virtual clock. So if this was a processor and all of these variables were registers, then and the if statements were like checks for comparison, like for equality, then modifying the logic like this would make sure that this step happens on the same clock cycle as checking whether the profile has been completed. If I had an else if here, it would be a different logic, and those little details they're not very easy to always think about while writing the code. They become more apparent when unit testing the code. So let's see if we can compile this now. I don't need that function anymore. Or do I? Actually, I do need that function. But I'll just test if plan state equals motion profile completed. Just like the function, just like the normal implementation of this API. Okay. Is there anything else? Target pause. Oh, yeah. Let's rename plan to plan target. Oh, did I forget that? I see. Extern C is going to be just for this stuff. Okay, so the test failed, obviously. We can test. We can see what tests. Let's see tests. Control, and we have. Actually, I'm going to test the motion profile. And motion profile has failed as well in the initial state, which is explainable, of course, because I think my previous my previous assumption was that it was completed, but I think that's wrong. I think it's wrong to assume that it's completed when it hasn't even been planned. So let's see what's going on here. So we have 103. And it's set to let's see. So obviously this needs to happen after this one has been clocked. So this will start the motion, the first motion. Let's make this. Let's start the motion to position number 1, and then we'll clock it once, and then we set the target. But after we have set like that, yeah, and then we can have another clock there. So if this is working correctly, then these values are not supposed to be updated once we get here. Set that to 4, and target pause should still remain the same. But this first clock will trigger from will trigger the state of the motion profile into accelerating. At least it should do that. And then once the motion state has been motion profile has been completed, then we should get the new target position set or sent to the motion profile API by the controller. We obviously need to handle the start state. So if we're not moving, yeah, so this should handle the start. And moving has to be false by default. So let's see what's going on here. So we have set target. We'll set the target as new target. We'll toggle the start, and then we get here, and we should end up here. But this should not be. Let's see. Is the motion profile state actually reset? Yeah. The state should be set to uninitialized there. So completed should return false when it gets there. Let's see. Oh yeah, of course. The velocity has to be 0 because it's always 0. And plan target position, there needs to be, it's set to 2. And then it should be set to the new target. Why is this one not working? So target position here. This has to be set to new target because, and the new target. Now wait a minute. Let's see. All right, yeah. So the new target is going to be 4, which is set here, and then it should be set to the new target here. So this needs to be equals to 4. I wonder what else I should test. So when I set the motion profile completed, then and when I clock this once, then I should expect false from move plan. Let's see, or actually control moving should be false, and start should be true. No, actually, start should be false there. Yeah. And then we have set target for the new, and here it should be true, and it should remain true here as well. Ah, of course. Or let's see here. No. I should expect this to be true there, but then when I clock it once, it should be set to false, because we should expect moving to be true as well, or moving will be set to false. Oh yeah, of course, yeah. I have to clock this once again because moving, or do I? No, that shouldn't be necessary though. Let's see. I have control start is true, and it's in motion. True as well. And then I have this will set moving to false, and then it will get here, and if start is true, start will be set to false. So now I should have moving and start false after this single clock. Let's see what's going on. Oh, I forgot to set moving here, of course, because yeah, we need to set the state to motion here, and we reset the start, and this should be yeah, velocity is supposed to remain the same, right? So it shouldn't be changed there. And then here we should have velocity set to 0. And moving on 15 here, profile completed. But if profile is completed, then moving should be set to false. And of course, yeah, we need to clock this again. This clock is going to be the simulation of the clocks while the profile is being traversed. And then because if we don't do this, then start will be, let's see, we expect start to be true there. Right. No, actually, this is not correct. What it should do, is actually start. Yes. This is, of course, supposed to be true because this is the start of the new move, so moving must be true there, and start has to be reset to false. And then we just check that, and then the last test. Yeah, let's see what this produces. And this should give us all green. Awesome. So there's a lot more testing to do. A lot of things like figuring out those little details. This is very nice. This is an easy way to debug. Instead of flashing this to the board and trying to figure out what the hell is going wrong, going through this logic in a unit test is just a lot easier. So I'm going to stop this video now, but there's going to be more videos to come, and have a good day.